So this presentation that I'm going to present, I'm going to go through quite a few just to get to the technical parts. This presentation was delivered at the International Passive House Conference this year. Myself and Michael talked about it, preserving cities through Passive House. I don't really preserve cities through Passive House. I do them one project at a time. Michael's the big thinker and the architect and getting the message. But how I impact the communities and the cities is by bringing the technical information and really diving down into the system. So we'll bring you through this project. It's a beautiful block in Brooklyn. It's a quiet dead end street. It's a really interesting section of Brooklyn Heights. It was amazing to work there for 2 or 3 years, back and forth as the project went on. So shout out to the main Michael as the architect of the firm. The architect working on the project was Mark Fabris. The Passive House consultant was John Mitchell. I did all the air sealing, the insulation, blower door testing, and kind of like fostered it through. And the general construction team was Robert Tafara and Tafara Construction. So this is the team from Baxingui. Everything they do is great. They're a wonderful team. You've seen all the presentations that we've done with them. This is me. This is who I am. This is my business. So Brennan Installation and Airtightness. I specialize in installation and airtightness, technical details, and trying to make the difficult easier for the general contractors up there. John Mitchell, amazing. John Mitchell and Ed May are amazing Passive House consultants. They take all the front end design work and make it into the models. And some of the information you'll see here was created by them, and their work stands out for itself. The existing additions of the site, it was an older, carriage house. Originally was designed as where they kept the horses in the neighborhood, and maybe the caretaker of the horses lived upstairs. But as the years have gone on and gone by, we now have this beautiful building, and it wasn't really used to its maximum potential. It was used as mostly a garage on the first floor and like a small apartment on the top floor. So its next life for the next 100 years, you'll see how we took it from this to something different. It's on a block that has some really great renovations. I think Baxingui did the project renovation of the project on the right, and we did the one in the middle. The plan was to take back the roof, so to make the roof useful and an outdoor living space, and they did a great job. That little outdoor compressor over here is the only heating system for the house. So it's a small but beautiful and awesome project. So we got the bones, the layout, the technical architectural details, but let's get into maybe some of the challenges. So this is the facade before and the facade afterwards. There was some tuning up and dressing up of this project, of that the window in the middle then became a triple window. They matched the brick to make it more traditional. As you can see, the older brick was not really matched to kind of like the quite preservationist level that really this project deserves, or the neighborhood deserves as well. All right. So in progress photos, there was a lot of technical air sealing. I'll get to those stories. Beautiful open interior stairs with skylight, the rendering, the actual finished product, and then the intro, during construction process of the pictures or so. This is another before and after photo of that. It was mostly used as a garage, and now that entranceway is now a part of the living space. There's a small little garage separation. This entire ground floor, it was kind of like, it was a really small basement mechanical room underneath. They dug out the entire ground floor to go down to achieve extra square footage and use that space, as you'll see in some of the other photos. So the typical Baxingui approach is listed here, the systematic approach to Passive House. But you can see in the drawings from Ed and John that we have some windows that are adding a lot of heat on the sunroof there, and then some of them are losses or so. So it's getting good gains in that bulkhead. All right. So this project and all the projects that we've worked together, we've put together quite a great team. The architectural team, the Passive House consulting team, all the other subcontractors and designers that work on the project. But really who has the keys to the steering wheel is the general contractor. So Tafara and his team, we've worked on, this is our fourth project together, in that we are working together, coordinated to execute these details. So they know what we're doing, we know what they're doing, and we have everything rushing together. But it's 4 or 5 past projects that we've worked together on a on the basis or so. And these are the two main guys making things happen, and these are where the rubber meets the road. So this is the project manager, site supervisor, Lubo, and he's transferring over his information to the new project manager, taking over, taking it past that last few yards, getting it to the goalpost. That's Fergus, and they're technically going over one of the garage details on the plans, and then we talk about how we coordinate and make it happen in real life on site. But it's a real good quality teamwork to Farah Fine Finishes and Ingui Architecture, Mark and his team, and me and my guys as the executors, meaning kind of getting everything running. So this model, when we first look at the page, it's like, well, what's really happening here? It's a smaller project. It's challenged by its surface area and its surface area to floor ratio. It's also challenged on its surface area to volume ratio, which to me is a hard topic to really kind of like grasp, because airtight should be airtight, shouldn't matter the size, but there is a certain volume area that makes passive house more difficult or easier. And because we're changing the geometry of adding up top and going down and taking out the garage, the surface area really increases, and it makes it more challenging, makes the details a little more technical. So details, details, details. On the upfront, trying to figure out these details prior to the excavation and everything, is a difficult process. So the team did a wonderful job of putting together all these details, and then we on site try and figure them out. And how we figure them out is we'll go through our process. So our first process was selecting an air barrier. So on this project, we had a substrate which was very unique to the neighborhood, of that normally above grade walls are not really field stone. That's normally left to below grade. The rubble foundations are normally below grade, and then they'll build brick upon. But at this project, they were taken all the way up. So they were like structural, 2 foot thick walls. The challenge wasn't so much the thickness of them, but how they were put together, the mortar, was it really tight? And then there was paint on top of them. So our normal process is that we like to use a fluid applied air barrier on these masonry surfaces, and we clean it up, we parge coat it, and then we do it. But on this one, we really couldn't, none of the manufacturers or the products we were looking at really had any data or research as rubble wall or field stone as applied to that area. So we gave it a time study, and we did a comparison of the fluid applied versus the Adhero, which is a peel and stick product, the membrane that was put on there. And as we went through it, the touch-ups required to make the Adhero monolithic and a true air barrier and continuous was just a little heavy on the labor side. It was like 4 coats and quite a bit of material and pointing and fixing. So what we discovered was that the Adhero product would work as our air barrier on the party wall and the front wall. And it was technically acting as an adhered membrane, but we were fastening it. So it had the extra durability of being thick and stuck on the wall, but it really didn't need to be stuck onto the wall. It was just a convenience. So then we mechanically fastened it back. But this is how we made the decision, and we compared the two. I took a video of doing the Viscon and how long it took, and then doing the Adhero, and it seemed the Adhero made more sense from a technical point of view of labor to material cost. So our next challenge as we go through selecting the air barrier, coordinating, is this excavation. So if you can see the excavation that's happening here, down here, they're digging down well deep, almost 12 or 14 feet, in order to gain a basement down below. They're not only digging down, but they're also adding a window to a courtyard, which is kind of unique to this shape and structure of the building. So then they're going to bring visible light in, but now that's an outside wall below grade. It has new footers, new foundation, and a whole new drainage system. So as we go through construction, it was the challenge, had to wait for it to get dug out. We started the air barrier on other floors to try and keep progress happening. All right. Where's my clicker? Hello. All right. So we also took on the the detailing of the vapor barrier. So for me, the vapor barrier is a very important part of the project because we want to make sure the house has a strong water resistive layer, vapor control layer to stop rising water and vapors from coming below. But it's also a part of our air barrier system in that it has to be detailed and brought up. We like to bring the vapor barrier all the way up to the wall, almost make the basement into almost like a swimming pool, just because we find it makes it a little easier to bring that detail up than to try and just bring it up 2 feet. We did all the details. There's quite a few penetrations. There's a bench there, painstakingly thorough to get that heavy duty 15 mil poly membrane underneath that bench for the structural reasons. But we did a good job on detailing, coordinating. All right, here's where the good details are starting to happen. This is where creative people coordinating makes the world of a difference. So the first picture you see up here is those are a joist pocket. That joist pocket is for a piece of steel that you see down here. That gets painted with the air membrane all inside the joist pocket. Then the steel gets placed inside of it. And then at the band where it's going across here, we're going to put a ledger, which is then bolted onto the wall. So we have air barrier behind it using the peel and stick. You see the green sealant around it. That's a part of the Proclima system on each one of those bolts to make sure it's super duper airtight. And then they put the steel in, and then they pack it in with concrete, and then we'll airtight to the steel as well. So we have like belt and suspenders approach on airtightness. We're coordinating and putting in the membranes systematically to make sure it's happening properly, and there's backup. So moving on. So as that ledger comes across in the front, this is the party wall. This is the front wall. We have the adhero going across the wall here. It's all being strategically placed in as a floppy bit or a piece of membrane. It's going across, and then the Intello is being put on that first joist, the first joist that's being put in, and that's being folded back. So it's quite technical how to get it in there, and then it'll wrap over once the subfloor goes back in. So we're using the flexibility of the membrane to make those turns. The inside corners are quite bits of a pain in the ass, but with the right products, the right system, you can make those folds work, those inside corners. The other picture you're looking at over here is our the existing joists. So on the between the first floor and the second floor, those joists stayed. So when they stayed, we had to prep them out and we had to clean them up, sand them down, make them smooth, and we use the Solido tape to tape all of each one of those joists. So it's a pretty technical process to make sure it's done pretty. This is the condition of the joist. The joists were all rough, kind of rough sawn, 120-year-old joist, and there's mortar that's been taken out of here due to movement. So we had to smooth it out. We sanded it, made it smooth, and then we filled all those gaps with either foam or sealant or cement. And then we strategically taped each individual joist. So it was pretty painstakingly thorough to hit those goals. Our next challenges were that the separation between the garage was a Q decking floor that had concrete poured on top of it. And because of the shape of the Q decking and the requirements on the energy model, we needed to put in a high R value insulation onto the Q decking and then fill the rest of the space with cellulose. So you see here is the spray foam, which we don't love to use it, but in certain applications, it does help with thermal bridging and fully adhering insulation to the underside of Q decking was quite the challenge there. And then the plywood was our air barrier underneath, and we're detailing out some of them. The other challenges we have is the bulkhead. The bulkhead had a kind of like a semi-party wall here, the neighbor, and then there was this little alcove here, and the creative teamwork that happened here was pretty amazing because it's so small of a space that the roofer who was doing the outside made this and slipped it in, made it with rigid foam board as the sheathing. and then put the waterproofing on the outside there. And then we were using the spray foam to make the connection details. And then on this side over here on the right side, this wall here is what you're seeing on this side. And then it gets the membrane and it would get blown in cellulose. But now this is an additional bulkhead that's on top of the building. Added a skylight, the stairs that go up there. I'll get this annotation thing down. Are you guys seeing the red dot when I'm putting it on there? All right, great. These are the technical details. So this is where the Flixo, the thermal bridge model, is informing our design decisions. John and Mark are all making the decisions on how to make this one solid thermal bridge free connection. The critical detail is the rigid foam separating the unconditioned slab to the conditioned slab. This is in between the mechanical room in the newly formed basement and the conditioned space on the inside. So we wound up using a sheathing product that was also the air barrier, taped the seams and brought that all the way down. But this really had to be coordinated pretty well to make sure that this happened strategically and that none of the details and the thicknesses were proper. This is the next technical detail. This is the penthouse to a window. So if you can imagine, the penthouse addition is up here. This is the outside roof deck, and this is the floor of the penthouse, and this is the roof system. So it's a real technical kind of connection. The steel was the hard part. That was the thermal conductive area there. And what we found doing is filling the ceiling with insulation. Top of the roof got rigid insulation up there. The sheathing came all the way down first to create that thermal bridge free connection. Right here was the real technical part, making sure the roofer was coordinated with the whole system, and then making sure that the window sat in the insulation layer, bringing back so there's like 5 or 6 different details in this one drawing that needed to be addressed. Now, this is an area where that alleyway window was coming in, and this I-beam was now technically in an outside wall. And the way they mitigated the thermal bridge was with I believe this was Armatherm. This is 2 inches of Armatherm, can handle the weight of the I-beam. And then we had to isolate the thermal conductivity of the I-beam in the back. So we filled it with spray foam, overfilled it with spray foam a little. The masons didn't like me that day. They had to cut out that foam a little bit, and then they packed it back in with brick and mortar. So, and you see that the Armatherm is down there, but there's insulation behind it. So you're isolating the thermal bridge of that I-beam. Pretty technical, not rocket science, but building science. As well as when you go up, they added structure on the roof. The I-beams up top needed to be thermally isolated. The way we used it was packed in. The I-beam was up. You can see the I-beams up here. It was packed in with studs to add the framing in, and then we had to install a rigid foam board around it to then stop the thermal bridge of the I-beam that was put in there. The rigid foam board helped us to have high R value insulation in those areas, and it took us down on the ceiling height. But we also needed to coordinate the airtight layer, which we used as the Intello membrane. So you can see the next photo, just painstakingly thorough, making sure everything is fit and tight and foamed. There's no gaps, there's no deficiencies around, and just making sure it's on the I-beam, it's connected. So Mike from my team is filling in all the little pinhole gaps or cracks around that. And this is what the finished product looked like. That's between the bulkhead and the I-beam that went up there. This envelope model shows really how complex this project really was, in that we added a bulkhead up top. The mechanical room was taken out of the enclosure, and there's also a garage that's out of the enclosure as well. So if you can imagine that the insulation all needed to be pulled out and then down in that room, and then we had to add structure above. So it had some real challenges for airtightness and thermal bridging that needed to be actually executed, and it was quite the challenge. I think we're going pretty good on time. As the as the airtightness and insulation contractor on the job, we started doing the air barrier in August of 2020. All the fluid applied air barrier went in, the party wall air barrier, everything that could be done as they were excavating. From the start of the air barrier to when we actually first got our blower door test on this first project on the first time was in June of 2022. So that's after excavation, all structure. The timeline really wasn't quick because of the structural needs that it needed to be put up there. But as the air barrier got put in, we started testing early. Window order was not really, it was staged. It was a split order. Some windows came in, they got installed, and then the next round of windows came in. Our first try at air tightness was a miss. It was 1.9. And then after quite a few days of using the smoke stick and trying to find the leaks, we waved a white flag a few days later. So meaning we're testing the project with the windows and doors that are not installed masked off and trying to find all the leaks visually that we can find using the smoke stick, blower door guided air sealing. And what we found out afterwards was that we didn't mask things up as best as they should have. We should have masked them up better. It wasn't bulletproof, so we were chasing fake leaks. So that's me all sweaty. I'm tired and frustrated of like, I can't find any more leaks. I can't find them. We took an innovative approach of like, we thought that the only area we didn't really finish all the details was the mechanical room. So then we pressurized the mechanical room to find some of those leaks within the vapor barrier. We took a little bit of a pause. We waited, and then we got the windows up on the bulkhead and the other areas, and we were able to keep notching down the blower door numbers as well. So we were at 1.5, and then we finally started to get some good numbers at 1.03 in August. So that's where we said, all right, we got this. We're within striking distance. So now let's make sure everything's still, as all the finishes are going in, that we're right there. We're at 1 air change per hour. Like we could start really going gung ho on the finishes and the drywall and the system. And the final end result a few months later after the finishes came in was 1.91. So for the surface area to volume ratio being a challenge, all the technical details, the ins and outs coordination of other subtrades from roofers to sheet standing seam metal installers, skylights. It was you name the challenge and it was there. And we were able to get air tightness on this project. And the finished photos. So the finished photos really speak for this project in that the envisioning and the designing really comes out in the finishes, hidden in this cabinet, in this beautiful, in this, sorry, in this beautiful laundry room. This is where the ERV lives. It's a really nice location. It's a really nice cabinet. You wouldn't even tell that there's a ventilation unit there. This is a heat pump. I think it's a heat pump all in one. So I think it's one of the washers and dryers that does washing and drying. It's a heat pump, so it's a compact area for the family. The kitchen cabinets are phenomenal. The stairs are really well designed. Open floor plan living space. This is the kitchen. The kitchen, they kept the existing joists. They were able to use them as an architectural detail. Looks great, makes you feel like you're in an old carriage house.
Yeah.
And this is the basement. The basement down here, which is now kind of like a small micro gym and a TV sitting living area down here. It's really a useful part of the actual property or so. Bathroom is wonderful. You know, all the finishes of Tava curbless shower, soaking tub right near an exterior wall that wouldn't be allowed. You know, wouldn't be comfortable in a passive house. Outdoor roof deck that's actually, you know, useful space, not filled up with refrigeration equipment and material. And then inside that bulkhead is kind of like a nice open to the outdoors home office. And it's really a wonderful project. It's very proud to have worked on the project. and to stand by that the blower door test results are of high quality finish and results as these finishes are as they're completed. So the fine kind of like finished carpentry is just as wonderful as the air sealing and insulation that's behind there, and the results speak for themselves. This is two QR codes to the videos. There are two videos of this project. One is during construction, and one is afterwards. So one during construction, I'm on with Michael. We're touring some of the projects. I am a sweaty, fat mess during that video because I was working all day, and the video came, and it's a great video. You see all the details. The one that's great is kind of the reimagined buildings one where the owner really takes you through the house, how they're using it. They're proud of the project, and it's a wonderful video. And I'm not in it all sweaty and messy, and but uh, those are the technical details. If anyone has any questions, I'm happy to go back or share. We're at
Bravo, buddy. Great stuff. I mean, gorgeous project and even a beautiful slide deck. So, give yourself a moment here, and we are going to head over to thank the sponsors.
Hello. Yes, that's me. Thank you so much to our sponsors. They are the ones who make all of this possible, and so we can bring this programming to you. First of all, I want to thank our stakeholder partner, that is NYSERDA, the New York State Energy Research and Development Authority. We'd also like to thank our founding sponsors. That includes 475 High Performance Building Supply, Glavel, Ingui Architecture, Minitaire, Partel, Rockwool North America, Stillcorp, and Zola Windows. Thank you to our champion sponsors. They include Bewiso, Gradient, Icon Windows and Doors, Intelligent Membranes, PH Air Seal, and Source 2050. And finally, thank you to our patron sponsors. That's Brennan Insulation and Airtightness, Euroline Windows, Holzrum Systems, Initech Windows and Doors. Sorry about that. Lanolux, Longboard, RDH Building Science, and Sanderson Sustainable Design. Thank you, everyone.
Thank you, Jay. That's great. Mr. Inky, did you have a comment before we head over to questions?
I did. I wanted to say that this was a really fun project. We're actually doing one right down the block that's very similar to this with a client who bought a carriage house who wanted to do a passive house because they followed this project. So it just shows you that people can get pretty excited when they see it. But I wanted to say something about Mr. Kevin Brennan. I am really lucky. We get to work with Building Type. We get to work with Kevin Brennan on these projects. I feel like I'm in school every day. And Kevin kicks ass. And Kevin does initial blower door tests. So it is the number one question I am asked during construction with contractors. Do I really need to do the initial blower door test? I know I'm good. I've done like 3 or 4. And if Kevin Brennan, who's at the top of whatever game we're talking about, ahead of whatever curve people are thinking about, riding the biggest wave ever, does initial blower door tests and still finds stuff every time and then shares them with everybody afterwards continuously. Everybody should do an initial blower door test. And I think it does make a difference. It made a difference in this project. It let us fly through finishes. And in fact, I think saves time. Yeah, we got to pause to do it, but it really winds up saving time. It just does. We flew after that because of that level of confidence. So I wanted to say initial door tests are cool. And the other one is that Kevin Brennan seriously kicked butt. So see you later.
Excellent. No, great comments, Michael. I mean, you look at the slide deck, you look at as Kevin was alluding to, just the quality of the finishing level. Again, the homeowners know that what's happening behind the walls, there's some great details. And Kevin, I forgot that I didn't make a note here. I got to see that stage December of 2021 before we started doing blower doors. And I'll be honest with you, I remember walking around being like, this thing is blowing my mind because the level of details that were going on here, I was just completely impressed because you're just, how you were so sold on the Viscon, on the air barrier, and and then you switched over to, the Hero because this is just like, okay, man, like I got no comments. I'm just in awe of the process. And so it's great to see the final product. So great stuff. And I mean, I think what's really cool about your team and, I mean, yeah, you get Michael too and his team at Ingwe, but where you're involved in integrated design planning session. I mean, I'm seeing this all the time now. If you're not having that team at the beginning of the project to just formulate, and the fact that you guys have experience where I'm sure you're at a meeting and you're finishing off sentences because you guys work so well together. I'm pretty sure it's pretty phenomenal. So that being said, is we got to get into questions, and I apologize, everyone. I'm actually in Germany, but I feel like I'm in Vancouver because just of what's happening. I'm here to celebrate Proclima's 30th anniversary. So a few of the friends that you normally would see here are already at the pub. So I will join them after we get through these questions. And Graham Irvin, you're right. I mean, you're right. Yoda level of detail. And we'll get to your questions shortly here. So
Well,
first,
Sean, the reason we're able to take that level of confidence and switch is because of the airtightness system that Proclima puts out there. It's not just one component; it's a total system. If you like, really, that practicing what I preach, like choose a system, lean into it, use all the components and the reasons why they're designed. Talk to the manufacturers, what's best to use here. Go into the technical documents. Can I install this product and have faith that it's going to last for the next 20 years on a fieldstone rubble wall? And the answers are, I don't know. And it's like, I don't want to do what I want to know. I want to know. So what product do you have next? What's next in line? What can I use? And that's really where it comes in. And you're in the, 30 years of Proclima, and they've been great partners to Passive House and airtightness. So there are other manufacturers that have all the systems and components out there, but my message is always choose a system, stick to it. No play on words there, but they're mostly tapes and systems, and make sure that when you have to go out, make sure everything connects well. So
yeah, and I mean, I just seeing the facilities here, the quality and the fact that they are driven to support their suppliers and sorry, their clients with finding solutions, and the quality control that they do in their facility. It is like I saw some testing equipment that I mean, Kevin, you would blow your mind for just the details that they do. And I mean, that's on top of the QC that happens in the manufacturing facilities. It's next level. And of course, you see that when you get to play with these products of how good they are. Again, they overdo it when it comes to some of the stuff. It's pretty exciting. All right, I'm taking too much of the show. Let's get into the questions, and we have Forrest up. Forrest, can you unmute and ask your question? There you go.
Yeah, Kevin, thanks for the presentation. Really interesting. I'm curious what resources you have when communicating with clients the cost effectiveness of Passive House. We have a client who's like, oh, I want to make it work, but the initial costs are a challenge. We can definitely communicate the ongoing operational benefits, but I'm curious if you would recommend any resources that you use to show, okay, well, if we have a more cost on the envelope, we can decrease costs in other areas like mechanical systems, for example. So curious to get your input there.
Michael and his team do a great job working with the clients and getting them onto the Passive House level. The lever that's there is really the quality control and the delivering what you promise, in that it's going to be checked. It's going to be checked twice. It's going to be checked by PHI. Everyone's trained. Everyone knows what's happening. It's going to pass below a door tests, pre, post, and continuous. All the loads are designed to the levels of insulation that are actually in the walls. Anecdotally, the thing that I use to sell people on Passive House is one of our first projects was originally in Manhattan, designed with 13 tons of heating and cooling on the roof, and then they were able to get that down to 6. So, quite a big difference of what the heating and cooling load was on that mechanical side. That project went through a redesign, but you wouldn't have that outdoor space up on that roof without having passive house on that project. Literally one, you know, 36,000 BTU, 3 ton, three, might be a 4 ton, but a 3 ton heat pump outside, just heating and cooling for that entire project. And it's not loud. You're able to use that space. Whereas if it wasn't passive house, you would have had a boiler, a hot water heater, air conditioning, so what you're subtracting from the mechanical cost and the copper and the gas lines, you're investing in the envelope and the other systems. That's kind of where I live. But I don't have any technical resources on this on the sales of the actual project, but really the commitment to passive house, certified passive house, really makes it the team top, takes that next level. Kind of going in between uncertified, but you want certified results, really is tough, because then the onus goes on the architectural design team, and all the quality control is on like in-house general contractor. So
just to add to that a little bit, I've changed the way I've been handling this, even from what I've told this community in the past. In that, I think passive house is not the best name in the universe, and giving anything a title is really difficult. I usually am now just going item by item, asking people what they like. One, two, we're putting the passive house consultant work in our CD phase. It's just creating a better CD set. So I don't, all of a sudden the cost of certification is only a little bit more, because I'm not putting the entire passive house passive house consultant costs, thermal bridging analysis, the PHPP or WFI, depending on what you're using. All these tools are just helping us create better CD sets. They're answering questions like, how much insulation do I need? What kind of windows do I need? So the cost of some of that upfront work we're packing in. But after that, we start to ask people the questions. Do I want to hear street noise? If not, okay, I've got to get this kind of window. Do I want to have my house sealed from my neighbors, or do I want to have the open holes? I think if you hit things individually, it's just a lot easier, because it's all just better construction. After that, really, for me, the question is, do you want a certified passive house? Because a lot of these things equal a certified passive house. And the way I've been selling it recently, only because I've failed recently on another project, it's still a great project. It's just not everything I wanted it to be. And really, the point is, if you're not testing it at the end, you don't know. And as the owner, you want to test it. Why would you not want to test it? I actually think as the architect and contractor, you want to test it too. But as the owner, how do you know? How do you know what you just bought? So the only way to know is to test it, get the certification. And what's nice about that is you get that final level of quality control. But again, by the time I'm asking that question, the cost increase in the upfront cost in terms of architects and contractors is small, because we put all the passive house consulting work in our CD phase, because again, it just makes a better set. So I don't know. That was a lot of words. I hope it helped.
No, absolutely. So yeah, Forrest, hope that helped. I mean, when you have an experienced team, I mean, you're seeing the data come out is the dumb tax, which is a line kind of from Gord Cook out of Toronto, is just you're not having to pay for people to learn. And with these guys, like I said earlier, knowing their left hand, the right hand, they work together. I mean, the those kind of details just get taken out. And of course, the best mechanical system is a great air barrier. And so being able to have this air barrier in your mechanical budget, again, you're just kind of moving the line items. And so that's what I've been doing in a lot of our projects, is just making sure that the price increase from, say, your typical air barrier and WRBs, that gets dumped in the first line of the mechanical, and it starts to tell the different story. And I mean, as Michael just said, I mean, he's well versed, and I've definitely learned a few things from how Michael and Kevin approach and use the language to ensure that yeah, if you're not interested in passive house, Michael will give the stealth passive house in there to ensure that you get all the benefits that we all, deserved in our home. So, great stuff. All right. Long answer, but I hope that helped for everyone else. And I know, Forrest, you're on board with all this stuff too. So, moving along. Mr. Steve from Holstrom Group, where are you? I know you were on my screen a second ago. So yeah, unmute and I believe Carr said you had a couple of questions and we're doing okay on time wise, so fire away. Now, for some reason, my friend, we cannot hear you. You are unmuted, but there's something going on in your funny laptop. So, oh, almost
Is that
there.
working?
Yeah, there we go.
Okay, sorry. Yeah, I just said, Kevin, that what you guys are doing is just ridiculous. I did my carpentry internship after college as a restoration carpenter, and my question was just I'm scared of what you do because I know how hard it is just to be a restoration carpenter. But it was always so difficult for us to estimate, restoration work. And as soon as like I got my eye on this we've had lots of clients come to us and ask us if we'd be involved with energy retrofit. And I'm not that superhero. And I'm also like terrified of how you estimate it and come out alive. And I guess I'm sure there's jobs that are just like any industry. They're difficult that way, but I'm wondering, like over the years that you've done this, are you finding some like factors that actually kind of work for you for cost estimation on this stuff? Or is it really just like client know that it's going to be airtight at the end and I don't know what it's going to cost? Like, how do you do it?
The 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 teamwork that's been built in really starts and ends with the general contractor. So Tafara, the first one was really tough. We found some problems. Their estimating team, how they estimate these projects, they add in some allowances, I guess, for air tightness and insulation. And they really have it down as the subcontractor. I'm normally bidding it what my estimate is, and then for what the extra penetrations might be, or it gives my labor rate, kind of friendly in that area. When it's This project was really tough because my initial impressions of this project was, this is easy. It's a smaller house. But when you really got into the details of it, it was so much more technical than the 5-story one we did around the corner. So it is tough. And as much as we like to say that there are standardized details and every one of them can be fit, yes, there are standard base plate details, but there's always going to be unique details on every project. So you have to leave open some space, and just trust and communication, I think, is big between all the parties involved, of saying, like, we've done this before. This is what we estimated it'll cost. If something else changes, we'll let you know, and we'll give you what our best prices. And it's technical, and it does take some time, and blower door testing is painstaking. Nobody likes to pay for blower door testing, so it's included in my cost over the course of the project. Nobody likes to pay a blower door fee at the end, So it's my secret of making it.
Yeah. Thank you very much. Amazing.
Steve, did you have another question?
Well, I guess maybe just to respond back to what Kevin just said. I mean, even just the material costs, like these are not cheap materials. Linear feet of tapes and sealants, and like I just don't even, we model like all kinds of stuff in our models, and I wouldn't even know where to start because you can't see what's behind 5 layers. So you kind of sort of how these things are going to be constructed, but you don't know their condition, and it's just a ridiculous can of worms. And I just commend you, and I think it's so important. It's such a gigantic market share opportunity, but the reason it's so big is because it's so like tough. So congratulations for being one of those amazing people that's brave enough and pulling it off and still paying your bills. So that's awesome.
There's a lot more gray hair here from these projects than when I started, but
yeah, thank you.
And Steve, I thought Kevin's answers, this is why he's still a firefighter, because that pays for all these mistakes. But he's able to balance it all out. But
firefighting is his safe. That's his safe place. Firefighting.
Yeah, that's it.
cats need to be saved out of trees, guys.
But I mean, I think we all know Kevin here, there's probably more time spent sometimes he doesn't bill for because he loves this and he's trying to troubleshoot and work with his team and make sure that he gets the results that the team requires. And so again, Kevin, I know you well enough to know that I'm sure there's some unpaid hours there just because you're in it. And like there's probably days where you are a hot mess and you're just like, I could be a hot mess for one more hour before I get in trouble from having to race home and all that other stuff. So it's great. So moving along, Lindsay Klein had a question. Lindsay, how are you? Come
Hi,
on.
great. And I just want to say, Mike, such inspired architecture. And Kevin, you always make it happen. My question was about is in that looking at the basement, was that a sump pump over in the corner?
Yeah, that was and that was a sump pit that was connected underneath all the vapor barriers. So it was kind of it's our opinion that that's how the sump pumps should be. They're a sealed system, completely sealed, vapor barrier to it, and the cover fits on tight. But so just in case there is some groundwater that comes up, it can be expelled out of the building, not brought into the inside.
Did the building have one before?
No.
No, there was no basement. Yeah, so it
Yeah.
was just a small little recessed mechanical room just to fit the boiler in. So it didn't really. Yeah.
We included in every house in my world, every cellar floods. Period. I wish they didn't. I don't know why they do, but when they do, it'd be nice to have a sump pump.
Well, given what's happening in New York now,
Yep.
brilliant. Thank you.
Thanks.
And that's the other reason why we also bring the vapor barrier up as high as we do, is because when the neighbor floods, we want to make sure that that stays out. Because it does happen, and like just working as a fireman, seeing how water infiltrates all these basements and causes damage. It's like let's put the effort in to get the details right to make sure that the stuff that's going to be hidden by 4 inches of concrete is really robust. And done as best we can, because you only get one chance to do it right in those areas. So
Awesome.
thanks, Lindsay.
Thanks. So we're at the top of the hour, and so if you do need to leave, that's okay. We're gonna keep going with questions. We're gonna dive into the final 15. When it comes to updates, there's not much except that the accelerator will be taking July and August off, and we'll be back in September. And of course, if you're not caught up with the podcasts like I am, you definitely have time to get caught up with those. And if you missed any of the lives, go watch them as well. And of course, there's probably a magazine that you haven't read either too. So lots of stuff to get caught up with, and we'll keep going here. But again, if you do need to leave, have a fantastic, wonderful summer. We appreciate you joining us whenever you do and whenever you can make it. And if you've been hanging around for almost 4 years when it comes to these lives, you're a trooper. And if this is your first one, hey, come back for number 2. So continuing on with questions, we are heading over to Graham. You got a couple, so over to you.
First, just because I can't help myself, I've got a few quick comments. Another amazing project, Michael, from the Passive House King of New York. And Kevin, every one of these technical things I go to, I always try to steal something. I'm gonna get a detail here. I started going into your thing and it was just like boom, and the only thing I have is like note to self, get a wizard for the project. And the last thing, guys, like, wow, I'd almost guess that real estate in that area is worth a fair bit of money, but your clients are super lucky to have you. My question was why the mechanical room was out of the envelope.
Tough question. The mechanical room, in hindsight, did not need to be out of the envelope because it didn't have gas. So normally we put the mechanical room outside the envelope for the gas meter. So just in case there's a leak, it has a place to go and there needs to be a vent. This project did not have gas in the end. So that mechanical room was then put in that zone and out of the envelope as a design to deal with maybe the excess heat of the heat pump hot water heater that was in there, maybe some extra venting of the sump pump that was down in that room. But normally those mechanical rooms need to be vented. So just in case the gas leak comes in, it has a place to go. But this project was 100% electrical and didn't, it was the safer bet to put everything in that room. But normally that mechanical room in a brownstone is connected to the old coal chute that's outside. So it's vented anyway. So it's easier to put up that wall and keep it out. This project didn't have that traditional coal chute area, but it needed a mechanical room. And early on there was the electric gas electric hot water heater kind of conversation that was happening. But yeah, that's that answer. We could have probably gotten away without it, but
what's cool is during this project we had at least 4 that I can remember projects go from houses that had gas to all electric, and we started those projects as partial gas, partial electric, and they went all electric. So there's a bunch of houses in New York that that I've done at least that are in the same situation. And for me, the biggest change was better heat pump hot water heaters, and honestly, better looking ranges. All the big companies that all these high-end clients like now come in induction. And so, there's some gateways to all electric, and getting decent hot water is one of them, and having a range that you're still super psyched about is the other.
Good stuff. Graham, are you got any other questions?
Well, what water heaters do you like, Michael?
I know that was. I was like, wait a second, you're not done yet.
Ooh, dangerous question. Dangerous question. So the heat pump hot water heater that I have in my own house is the way I'll answer that one. It is an A.O. Smith heat pump hot water heater. I've played with it a lot because I can. And so if I had to install it again, I would do it the way it's set up right now, which is it's a heat pump hot water heater, A.O. Smith, and it has a timed recirculator pump. So it only recirculates a couple hours in the morning. I don't know that I really need it, but it's 4 stories. I have a 16-foot wide house, guys. That's tall, so it is what it is. Anyway, whatever. But it has a my God, what is it called? The thing with that makes it 150 degrees and brings it back down.
Temporary valve.
The aquastat.
Thank you.
yeah.
So it allows the hot water heater to operate at 150 and bring the hot water down to 120. It basically brings that hot water heater down to basically 4 showers where it happens stock. It never runs out of hot water. So, and they work really well. And we've had them in a lot of clients' houses now and set up that way, and everybody likes them. There are definitely other models and other things. We've used a couple of the versions where you've got the outside compressor, inside tank. It's nice to have everything in one spot if we can. So, and we have mechanical rooms, so it's easier.
Oh, Graham, other thing, as far as Wizard or, like me and my team, we're really technical and making sure the details happen. You don't need that. What I'm finding is you need somebody to lead the exercises, the workshops. So bringing in the technical detail and breaking things down to off pen and paper, just actually about the detail, and doing little mini mock-ups really helps the team to have confidence in the ability to do the work. So on that next project that they're doing down the block, I'll be more of a training consultant and an inspector trying to help that team, but proving that it can be done, executing it, building confidence. You can build people up to that next level. And, with the level of skill and professionalism in the market and the place, a finished carpenter and an airtightness guy are the same ones. They're just focusing on different things. If it looks perfect in airtightness world, and it looks perfect in fine finish world, it's perfect, but we also test it. So, but.
Mike, just a question that too. I mean, Monty's pattern language course, he talks about mechanical rooms first, designing them and making sure that they, fit things. So did you guys actually, again, design, mechanical room that would fit everything? and that's why you kind of knew what to dig down because you kind of knew what the specs were. Can you just
Yeah.
kind of dive
Yeah,
into that question?
I think there's a couple of things. One is in this house, the mechanical room's low. It's a two-story house. We're putting a hot water heaters up. We're putting thanks. We're putting our hot water heaters up high now, so they're even closer to where people are using the hot water. And so in that case, sometimes the dual units work really, really well. By the way, I almost forgot one of the coolest things that I saw at the Humid Climate Conference was LG's hot water heater, the heat pump hot water. It's like this cool, sexy little machine. I haven't used one yet, but it might be on our next project. But it's very similar to the A.O. Smith, where it's a tank that you can put the mixing valve on. But yeah, I think getting your mechanical rooms so they're laid out so that they can work properly is important, to the point where like your client can get to stuff. Your client can actually remove and put in filters, and you can really see things. HVAC equipment that can't be reached won't be serviced, period. Um, and hot water heaters go and they need to be serviced. So making sure that you got it all together is really important.
And on that point too, was that room like 8 foot by 8 feet by 8 feet?
No, that's a lot of money in New York City. Um, so I think in that area, real estate's worth like 3,000 a square foot as a kind of a comparison. So no, that was actually, Kevin, you know more. You spent a lot of time in there, but it was about 3 feet, 3 or 4 feet wide by the whole front width of the house, and where the hot water heater was about 6 feet by 6 feet. But we minimize them as much as we can.
Yeah, no, I get it. And again, like depending on the pathway, that could be part of the mechanical room, or it's a closet or a hallway, depending on what's going on there. Excuse me. Okay, so we've got one more question in the hopper. So well, if there's anything else, put in there. I'll read the chat while we get to this question. And Nadine, you're up if you want to unmute.
Oh yeah, I was just well, I'm new to Passive House, but then I realized that you're saying that it's so insulated, they didn't need a lot of condensing units. But so there was a condensing, I mean, it was VRFs that were used on this project. What was used to heat the project, heat and cool?
It was a Mitsubishi. I don't
City
think
Multi.
BRF.
Yeah, it's a Mitsubishi City Multi, and you don't really need to heat them. I would say maybe we're heating them a couple of nights, or maybe a couple of nights or a couple of weeks out of the year. But we're designing everything for cooling. Still got to cool in New York. Still have to dehumidify, and I saw Scott Kennedy here before, and he gave
So
me
it was
my
a
best.
split system?
Split system, and I've been told before by others that shading is the best thing you can ever do for cooling. So we've been taking it much more seriously than we ever did before. But it's a split system. I think if you do the shading properly and really pay attention to your window specs and everything else, I think you can get that cooling system down. But yeah, it's a split system, Mitsubishi.
Oh, so the windows had over shading? Or you mean like pull down shading?
Well,
or overhang?
Interior.
It's different depending on where we are. We're in landmark district, so where we could, the roof overhangs. On the kitchen floor in this particular, on the first floor, we actually built an overhang where we have our largest windows. And the only place we couldn't do exterior shading, which would be your best bet, you want to get that sun before it ever makes it in, is we couldn't do it on the second floor rear because it's visible from the street. So in that particular case, we dealt with it with the glass a little bit, can only do so much, and we have interior shading. So you do the best you can where you can do it, but grabbing that heat before it ever makes it in, that is the trick, at least in New York where we are. But humidity is still going to be your not going to be your friend in New York.
Okay. Yeah, and I heard with Passive House, there's a lot of the humidity on the inside is a big issue.
Every house. So I would say every house that I've worked on 10 years ago that was done really well, Passive House or non-Passive House, dehumidifiers weren't as much of an issue as they are now. We are just seeing it on all of our projects. So a simple dehumidifier, I mean, the passive house still holds the humidity out. It still does a really good job. It's still, when you think about it, it's in the most simplest way. It's still a thermos, still working well. As long I keep my windows and doors open all summer. So if you don't keep your windows and doors open all summer, the dehumidifiers would do a lot, and they'll do a lot for the interior air. And it's only when you're introducing more humid air into the house where you're really having to work on it. But yeah, I would say in every house, a dehumidifier, at least in New York, a dehumidifier would be really helpful, because that means in your swing seasons, your HVAC system wouldn't have to work so hard.
Okay.
I could show you a picture. You guys see my screen? This is the split system we use for that project. It's only 36,000 BTUs, 3 tons. And it's just, that's it. So I'm not sure on the square footage of it, but it's a city multi H2, low temperature, kind of like heat pump if it needs it. So pretty remarkable for that project. So,
but I have to say that the point that was just brought up is a really good one. Dehumidifier. I feel like it's the thing that a lot of people miss, and it's what we need.
Yeah, I feel that a dehumidifier running in that mechanical room consistently 24 hours a day, 7 days a week, set on a humidistat really is an essential system in these tighter projects. This way it's on its own, controlled, simple, just runs on humidity and just constantly dehumidifies, as opposed to running on the thermostat and the temperature. Some of the systems that are coming out there, they're pretty reasonable in comparison to other systems. I don't, the manufacturer is missing my name, but they're active in the passive house community. They're out there. So.
Well, we got a couple more minutes before the final 15 wraps up. Graham wanted to know, where were the indoor mini split units?
So they weren't conditional wall hung cassettes. They were recessed ceilings, I guess, cassettes.
Yep. Yeah. So we have a cassette at the top, and then we very
systems.
often.
So they were ducted unit. One of them was in the laundry room with the lower ceiling that then fed the living room. I mean the master bedroom and the other rooms. I'm forgetting the other room, but the front and the back, and then the main living room. I think that was in a closet. I think the indoor head.
Mm-hmm.
There was one in the basement as well.
Mm-hmm.
The hard part was getting the AC up to the bulkhead. That was a hard part. That was the difficult space. It cut through my air barrier. You believe that?
Who does that? Only trades, not specialists, because specialists would talk to you first. They would read the memo at the front of the door being, any cuts to the penetration must be discussed to the air boss. Guess that guy wasn't around for training day. Kevin, it was funny you were speaking there where you froze for like a good 4 or 5 seconds. And I totally wanted to, I'm going to go back and clip that face of yours. That was pretty funny. It was kind of like one of those. It was pretty good. All right, everyone. We are the top of the hour, and again, I'm in German time here, and it's time to celebrate a few things. So, again, I appreciate you all being here. Roller coaster of emotions tonight. We thank you, everyone. But again, to be able to see this project come to life, and if you didn't see the note, the amazing Fire Hall has a ribbon cutting event this Friday. So if you're in New York, going out with some of our favorite special New Yorkers, the King of New York, or King of Passivos New York, and of course Kevin, make it happen, Brennan. I will definitely use some of those lines future in my life. So appreciate you all for making those things. And other than that, I think we're good. Unless anyone else wants to make or say anything else, we'll let Cara hit the ejection button, and we'll go enjoy the rest of our Wednesday, depending on where you're on this planet. So yeah, good morning, good afternoon, good evening. Take care, be safe, and we'll see you all soon.